my name is Kevin Vandecar. I'm with Autodesk. I've been at Autodesk for quite a number of years, 22 years in total, but I left for a little while and came back. So if you're interested in developing products using Autodesk technology, that's what my group is all about. We're part of a group called the Forge Partner Development Group, and we also run the Autodesk Developer Network. So all of our desktop products that have APIs, we support and nurture that environment, as well as our new web services under the Forge umbrella. So one of the biggest problems that we see with moving to these new platforms is model preparation. There's lots of 3D content out there already. Everyone has 3D content who's a manufacturer, who's a building designer. All of that content is there already. So one of the challenges, though, is to get that content into the tools where you want to display it. So HoloLens being one, VR environments, etc. And it always takes many hours. People who do creative experiences especially will spend days and days perfecting the way their models look. So one of the things that we did as an experiment, my colleague Keen Walmsley, he works in our Autodesk research group. So he wanted to see how easy it would be just using the traditional methods to get something working on the HoloLens that was interactive. So he basically created this dancing robot. So he used a model that already existed, but it wasn't perfect. So he brought it into Fusion 360, which is one of our mechanical design packages. And he did some work there and realized that it was already going to take quite a bit of work to get just some of the joints to behave the way he wanted them. So he actually went out and hired a modeling artist to create and massage this model. And again, it did take many hours. Some of the challenges were, this polygon simplification and optimization. The materials didn't always come through and look right, and rendering at the end wasn't exactly what he expected. So by hiring the artist, he got much closer, but it also cost a lot of resources to get there. If you're interested in looking at this, you can find the link in my slide deck, which is posted on SlideShare. So what we did next was another colleague of mine, Cyril Favel, said, well, hey, we've already got the Forge API, and one of the core services there is to take heavy models and translate them to a lightweight format that can be viewed on the web. And this is something that you can do today. We have developers that are using these services to create WebGL style experiences using our JavaScript viewer. So with no more work than sending your model to the translation service, getting it back, hosting the viewer, which is JavaScript in your web page, you can have a 3D experience in a web browser. So we knew that the data set was already fairly lightweight, and that's good for VR and AR experiences. So he wrote a custom parser for that package of data, and he plugged it into Unity. So we're kind of using the same kind of core HoloLens workflow, but with some custom code that can be reused to read any of these packages. Now we can get a model into the HoloLens pretty quickly and pretty easily. So if you're interested in this project, we are sharing the code at that link. So how does it work? So the Forge Model Derivative API is the core piece of this. It basically is a REST API that allows anyone who subscribes to the service the ability to upload a model of pretty much any format, check the processing of that model for the translation phase, and then once you get the model back, you have access to the derivative, which is basically the geometry and the information, plus all the metadata is there as well. So any data structures that you created in the source model, so for example, maybe it's a mechanical model and has assemblies and sub-assemblies and all of that, those parts are all maintained in that tree, and also the properties about each individual part is already maintained. So all that data is in this one package, and so he wrote this custom code to use this API to get that data into the HoloLens experience. So the SVF format itself is a proprietary format that we came up with, but it really is just a data set of JSON information. So we already support the Web VR initiative. We just came out with an extension there. So we've kind of got that covered with this, and the next step would be to move to the AR space more officially. The viewer itself is free, and it views these SVF formats. And like I said, it does support Web VR, so any mobile devices, etc., you can get that experience. So if you're interested in learning more, the QR code is here. It's forge.autodesk.com. And the slide deck with the links are, again, at my SlideShare account. Okay, so before we go, I just want to remind you that, please make sure to wear your headgear where appropriate. I believe that all of these new devices are really interesting and fun, but you can see that there could be some exceptions and problems with that. So thanks for having me.